All right, welcome back. We're talking about alcohols. We're picking up where we left off the last time. Last time we were talking about the oxidation of primary and secondary alcohols. And just to do a refresher here, if you have, let's say, methanol, all right, and we're going to add a strong oxidizing agent like potassium permanganate or chromic acid, and we're going to symbolize that by putting oxygen symbol in brackets. Again, oxidation means the reduction of hydrogens off of a compound or the addition of oxygen to the compound. Now, I know that can be confusing, especially for those of you that have had general college chemistry or introductory general chemistry. Generally, we think of oxidation as loss of electrons and reduction as gaining of electrons. And we generally see the product being a positive or negative ion, respectively. What we're going to see a lot of times in organic chemistry is the loss of hydrogen is oxidation, or the gain of oxygen on a compound is oxidation. So what we see here is we see a reduction in the hydrogen. We end up having a double bond formed between the oxygen and the carbon. This is called a carbonyl group. You definitely need to remember that this is this group here is called the carbonyl group. All right. Oops. And then we have the loss of this hydrogen, so we only have this hydrogen left over. So this hydrogen is here, and we lost what was circled here. So this is a aldehyde. This is called methanol. And then what happens to the two hydrogens and the oxygen is that we get water here. Water, oxygen from the oxidizing agent. All right. The next type of reduction or oxidation that we see is that where we have maybe a let's see, let's make this a 3 here, and we have something like this. All right. So with this type of reaction, we have two alkyl groups. Let me fix this. There should be a 2 here. So we have an ethyl group here, and we have a methyl group here. And again, with a strong oxidizing agent, we're going to lose this hydrogen, and we're going to lose this hydrogen. And so our final product is going to be this plus water. All right. And the first thing you want to be able to do is identify what type of compound this is. You say, oh, it's an aldehyde. No, it's not an aldehyde, because the key to an aldehyde is you must have hydrogen carbon double bond to an oxygen. And here we have two alkyl groups, or an alkyl group carbon double bond to an oxygen. So this is a ketone. So make sure you can identify the difference between an aldehyde and a ketone. All right, so this is a ketone, and this would be butanone to butanone. All right. So that's what we've talked about the previous video. I want to put one more. I guess we should go to another slide just to show you. I just want to make sure you understand this. Let's say I've got a carbon here, and attached to 3 other carbons like this. All right, and you're going to try to oxidize this. All right, so the first thing I want you to do is identify what type of alcohol is this. Is this a primary alcohol, a secondary alcohol, or a tertiary alcohol? This is a tertiary alcohol because this carbon in the center is attached to 3 other carbons. So because this carbon is attached to 3 other carbons and this carbon is not attached to a hydrogen, that makes this that doesn't allow this carbon to be oxidized, and that we lose this hydrogen here. So in this case, there's no reaction. So for tertiary alcohols, we cannot oxidize those because every one of the bonds coming off of this carbonyl, remember this is called the carbonyl. In fact, you should get this terminology, oops, let's go back. You should get this terminology down. This carbon has a name called carbonyl. It's called the carbonyl carbon. Yeah, it's not the best writing. Let's see if I can do better. Carbon. So because it's tertiary here, no reaction occurs. You cannot oxidize this and form a new compound. All right. Next slide. We're starting we're getting to why you need to know more about alcohols. And I really like this one because this one comes up so much. So let's say you go out for the night and you drink some bourbon. And in this bourbon, you have about 40% of this compound in there. So what is this compound? This is ethanol, all right? So this goes into the liver, and it's oxidized into this compound. All right, so what's the name of this compound? Now there's a IUPAC name and there's also a common name. So just like this, the common name for this would be ethyl alcohol. The IUPAC name would be ethanol. The common name for this is what? Well, it's this is the key right here, is to know this functional group right here. Now, if you don't know this functional group, you need to go back to the chapter 10 in the Denniston book and look at that table. It's going to be really important that you can look at a compound like this and identify the functional group. So this is the carboxyl group, and this is a carboxylic acid. And so the common name for this is acetic acid. And the IUPAC name would be ethanoic acid. All right. Oops, I jumped a step here. It does actually make an aldehyde between here and here, but I just jumped right to what the next oxidation product is, and that's this acetic acid. All right. So when this acetic acid is formed, our bodies will consume that, break that down into carbon dioxide and water. Now, so you're saying, well, what gives me a hangover? Actually, it is the product between ethanol, and acetic acid. And that is where you've oxidized it slightly and you form this compound. All right, so this is an aldehyde. This is ethanol. So if you want to know what's giving you the hangover, it's this compound. That, and you could be dehydrated. Again, this is the process. This is what we generally think of as the oxidation of ethyl alcohol into acetic acid. But there is a intermediate here of ethanol, and that ethanol generally gives us that morning after hangover. All right, so let's put this all together. Let's look at the next slide here. So we start off with an alcohol. So again, where R can be any alkyl group or aryl group. And then from that, we oxidize that and we get something like this. And that is an aldehyde. So why is it oxidation again? We've lost a hydrogen. So the loss of a hydrogen is considered an oxidation reaction. And then we can go further and we could knock off, or we could add another oxygen. That's what we actually did in the last step. And we get a carboxyl group here. Acetic acid was an example in the last one. So this is the process of oxidation. Now let me change the pen color. If we go in reverse here, we're adding, well here we're removing an oxygen. Here we're adding a hydrogen. This would be called, this process going this way would be called reduction. All right, so that's something to keep in mind. Alcohol, aldehyde, carboxylic acid, oxidation. All right, next slide. The next slide, I just want to point this out. And this is in your book on page 420. Page 420 in your Denniston book. We'll look at this compound. It sort of looks like a sugar there, doesn't it? All right, this COO that you see here and at the bottom down here, remember what that is, just kind of a side here, it's that, and we've lost the hydrogen. Remember, hydrogen is a proton. It's generally a positive charge, but we don't have the hydrogen, so we have a negative charge on that. So just keep in mind what this looks like as a structure, both of these. This particular compound is called malate, and that's its common name. All right, and we can add to that NAD with the positive charge. This is nicotinamide adenine dinucleotide. And the only reason why I want to point this reaction out to you is that those of you taking biology, you get into the Krebs cycle. There's two ways to do the Krebs cycle. One is you memorize it, and you just memorize each step. Or the other one is you recognize that the Krebs cycle is an oxidation reduction series of steps. And so if you can follow either the gain of hydrogens as a reduction or the loss of hydrogens as a reduction, let's see, gain of hydrogens as a reduction, loss of hydrogen as oxidation, or the gain of oxygen as an oxidation. You can make sense of the Krebs cycle without having to memorize it. You can actually derive it from what you know about chemistry. So what happens here is we're going to see a reduction. And instead of using an oxidizing agent, we're going to use an enzyme. And you'll start seeing things like this, specific enzymes that cause reactions to happen. So you would have malate dehydrogenase. And let's see, is that going to work out for me here? I'm kind of running out of room. I'm going to, let me erase that part. So we still have this carboxylate, and then we're going to attach that to this carbon, which now lost a hydrogen. So we have an oxidation there. We've lost this hydrogen, and we've lost this hydrogen. And then we're going to have attached to that so we see the changes right here from here to here. So we see it's an oxidation. We've lost hydrogen. And what's happened to the hydrogen? Well, normally you think of it forming water, but here it forms NADH. NADH. All right. So it's something to look at. It's something to if you're into the biology and you're trying to make sense of what you're seeing in biology, here's a classic example of an organic reaction where we see an oxidation, and that oxidation is shown by the loss of hydrogen on the compound. All right, the next group of compounds we want to talk about is they look like alcohols. But now we're going to have those attached to a benzene ring. Oops. Again, I'm working off my tablet, or the little tablet board today. It's not quite the same thing as a tablet computer. All right, so we have a benzene ring. We represent that like so. And then we can put a hydroxyl group on it like that. And this group of compounds are called phenols or phenols. All right. And the book talks quite a bit about these, like all these different phenols that you would maybe have come in contact, like thymol. Thymol, we would take compound. Starts out with your benzene ring. Let's attach the hydroxyl group. So that's a phenol right there. And then here we're going to attach a tertiary carbon. Oops, 3. And then 2 of those. Is that the way I want to draw that? I don't know if I really like it drawn that way. And then another methyl group up here. Oh, actually, it's a. Let's see. Let's do this one over. I think I'm missing something there. So we're going to start off with our benzene ring, methyl group here, hydroxyl group here. Now watch what happens. I'll put this here. I'll put a methyl group here and a methyl group here. All right. And sometimes you don't see the circle. You're going to put one here, you put one here, and a line here. So you can do it that way as well. All right. I don't know what to really say about this. We could go through a bunch of compounds that have this functional group, the hydroxyl group, with the benzene ring, which we can again just make a circle. That's probably the quickest way. And they talk about these on page 423. I don't really. I guess what I would focus on here is, again, you're looking for a benzene ring with the hydroxyl group on it. And then a lot of these are flavorings, or they have antiseptic properties because they can undergo reductions. And so that's what that's what you want to focus on. The main thing is that you know that these are phenol groups, or with the hydroxyl group. All right, let's go on to the next group of compounds. And these compounds look like this. They have an oxygen in the middle and alkyl groups on either side of the oxygen. So we would look at this group, and IUPAC, we would say this is methoxy. Methoxy, methane. And this group of compounds are called ethers. So you'll have an alkyl group, an oxygen, and then another alkyl group. And that's what's going to identify this group as ethers. Now, what you need to know about ethers, they generally have higher boiling points than their counterpart. Like, let's say I was looking at something like methane. So methane looks like this, or ethane. So here's ethane. This ether is going to have a higher melting point and boiling point than ethane. Remember, the force that causes ethane molecules to stick together are London dispersion forces. Well, you have the same thing here, but this oxygen is electronegative, and that creates even more attractions between something slightly positive charge and this oxygen here. Now, it's not going to have as high a boiling point as, say, if I looked at this as like ethanol. Or methanol. Ethanol. And the difference is that because of the oxygen-hydrogen bond in ethanol, you get hydrogen bonding, which we've talked about before. If you had another ethanol up here, there'd be a attraction between the hydrogen of this ethanol and the oxygen of another ethanol. So ethers do not have hydrogen bonding. Remember, hydrogen bonding only occurs when hydrogen is bonded to oxygen, nitrogen, or fluorine. And in the case of alcohols, the hydrogen's bound to oxygen. Over here we have an oxygen, but it's not bound to hydrogen, it's bound to the carbons. But because it is more electronegative, it is going to have a slightly higher melting point and boiling point than the alkane itself. All right, so how do you name ethers? Well, let's look at a few examples. So let's say I have a longer chain. I have something like an ethyl group here, then the oxygen, and I'm going to just accentuate that by here's my oxygen, then and then go like this. It makes it a little easier to identify. And then I have a group like this on the other side, another alkyl group. All right. So how would you name this compound? Well, you look at this first part and you look at the second part. And so this is the longest part. This is the longest chain. And what would you name this chain if it was an alkane, which means that it wasn't bonded here? It would be a 3 here. What would you name that? Well, that would be propane. So this part you name, this is according to IUPAC, this would be ethoxy propane. Ethoxypropane. All right. Let's see. What else do you want to do? You want to try another one of these? Well, let's go to another slide. I'm running out of space here. The book gives this example. It's written a little differently. So they have the oxygen coming off here and a methyl group coming off here. And then watch what I'm going to do here. I'm going to put CH2 like that. And so you could do something like that to condense that. All right. And so in this case, you've got a total of 1, 2, 3 plus 5 carbons. That's 8. And there's 9. So the longest chain is 9 carbons long. And then you have this group out here. So you would identify this group as methoxy. And you'd have to identify which carbon it was attached to. So it's attached to, you always want the lowest number, so this would be carbon number 3. So this would be 3-methoxy. And then the number of carbons here total is 9, so that would be nonane. 3-methoxy nonane. All right, let's look at another one. So this is a common name. This is not an IUPAC name. This is just, again, that's what sometimes is confusing, is when do you use what? Well, let's say we had this attached to an oxygen, and then on this side we had something written like so in this case we're saying these 2 methyl groups is attached to this carbon. So if you want to draw a picture of it, you'd have a methyl group coming out here and a methyl group coming out here. I mean, we could do that. And then erase that. So what's this group called that's attached to the oxygen? Well, because it attaches to the second carbon, this is called an isopropyl group. Isopropyl. So we could, the common name would be ethyl isopropyl. Oops. Isopropyl ether. What's another name for this compound? What would be the IUPAC name? Well, you look for the longest carbon chain. This is your longest carbon chain here, 3 carbons. So, what's that called? Well, that's propane. Then you look for this functional group, this attachment here. and that's called ethoxy. Now you have to tell the person that this is on the second carbon, so you'd say 2,2-ethoxy propane. 2-ethoxy propane. As opposed to if you had CH3, CH2, then the oxygen, then CH2, CH2, CH3. What would you call this compound? Well, this would be ethoxy propane. All right. So how do you make an ether? Well, let's look at another slide here. So an ether, we generally take an alcohol, so we'll call this our alkyl group 1 with the hydroxyl group attached. And we attach that, we react that with another alcohol, we'll call it alkyl group number 2 with the hydroxide attached. Then we add strong acid and heat. And I'm going to use the triangle for heat here. And what happens is we get alkyl group 1 attached to the oxygen, alkyl group 2, like so, and then we get water coming off. So it's a dehydration reaction. Or condensation. Yeah, condensation reaction. All right. That does it for alcohols. I'll create another video dealing with thiols.